Today we will be learning radicals. More specifically, there's 4 things I want to cover here: multiplying radicals, dividing radicals, simplifying radicals, and what we call rationalizing the denominator. So let's start with a few vocab terms here. Radical. Radical is what you normally call the square root symbol. So we call that square root symbol the radical. Radicand is what you call the number inside the square root. So these are just some vocab terms, radical and radicand. Let's move on. Multiplying and dividing radicals. Let me give an example. Example. If I have 3 square root 10 times 6 square root 2. The way you multiply radicals is you multiply the outside with the outside and the inside with the inside. So over here, the outside we have 3. Let me zoom in more. Outside we have 3. Out here we have 6. 3 times 6 gets me 18. Doing the same for the inside numbers. Inside we have a 10 and a 2. That means we have square root 10 times 2, which is 20. So 3 square root 10 times 6 square root 2 is 18 square root 20. And that's it for now. This square root of 20s, we'll take a look later on and see what else happens here. But when we say we want the answer to be in radical form or exact answer, this is what we mean. If we say we want the answer in decimal form, that is something you type in the calculator. Alright, let's do an example with division. Dividing radicals. Okay, let's say we had 3 square root 10 divided by 6 square root 2. When you are dividing radicals, it still follows the same pattern from multiplying. The outside numbers get divided and the inside numbers get divided. So on the outside, we have a 3 and a 6. 3 divided by 6 gets me 1/2. Inside, we have a 10 and a 2. They're both inside the square root. 10 divided by 2 is 5. So we have the square root 5 inside. So 1/2 square root 5. Or, the way we traditionally write radicals like this is square root 5 over 2. Multiplying by 1/2 is the same as dividing by 2. And this is the answer we normally see radicals written in. Alright. So next up, let's go over simplifying radicals. Over here I said 18 square root 20 is not done. Something special happens here with this square root 20. So what we do here is what we call simplifying radicals. The idea behind simplifying radicals is similar to simplifying fractions. Off here to the side, if I say 9 over 12, normally we don't leave the answer as 9 over 12. We say we reduce or we simplify that into 3/4. 9 over 12 and 3/4 are the same number, but when we simplify, the numbers became smaller. The fraction's the same, but the numbers are smaller. These smaller numbers make it easier for us to calculate and work with. So that's the reason behind simplifying fractions. So by the same concept, we also simplify radicals. So let me use square root 20 as an example. Before I start this, let's go over what we call our perfect squares. Because radicals use square root, and the opposite of square root is squared, we need to take a look at perfect squares. This will help us with simplifying radicals. So perfect squares are 1 times 1 gets me 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 gets me 16. 5 times 5 gets me 25. 6 times 6 gets me 36. A perfect square is a number times itself. 1 squared. 2 squared.
Students, tutorials are officially over. If you are waiting on
3 squared. 4 squared. 5 squared. 6 squared. These are square numbers. So we refer to these numbers right here on the right side as perfect squares. And we will be using that when we simplify our radicals. Here we go. So first we want to pick factors of that number. Factors of 20. What times what gets me 20? So some of our choices include 1 times 20 gets me 20, or 2 times 10 gets me 20, or 4 times 5 gets me 20. These are my 3 choices. Of the choices here, what we want to do is to pick a factor pair with a perfect square. So that means 1, 22, 10, 4, 5 from these sets of numbers. Compared with my list of perfect squares here, I see 4 is a perfect square, so I'm going to pick that. That means, my example, we can take square root of 20 and rewrite that as square root of 5 times 4. So looking at this, now we ask ourselves, can we square root these numbers? Can we take the square root of 5? Will that give me a whole number? Square root of 5 gives me a decimal. We cannot do that. Can we take the square root of 4? And will that give me a whole number? Oh look, it does. Reason it gives you a whole number is because 4 is a perfect square. That's why we pick perfect squares. So square root of 4 is 2. That means we can take that 4. It goes outside as a 2. Square root of 5 is a decimal. That does not work. We don't want that. So it stays inside the square root. So your answer is 2 square roots of 5. We call this the exact answer, or answer in radical form. On the calculator, if you were to type that in, 2 square root of 5, gives you that funky decimal. So this is approximately 4.47, which is what we call the answer in decimal form. Normally in math, especially when we get to upper level math, pre-calc and above, they're going to want you to keep your answer in exact form, radical form. Reason for this is each time you round, you have a little bit of rounding error in there. And when we start working with bigger and bigger numbers, the more you round, the more off your answer will be. So you want to keep everything in exact answers. Alright, let's revisit our earlier question over here. 18 square root of 20. So we said that square root of 20 can be broken down and factored out and all that good stuff. Square root of 20 is square root of 5 times 4. When that 4, we can take the square root of that 4. We can take the square root of that 4 and make it come out. So what we're going to have on the outside, the 18 is still there. And now it's going to be multiplied by that square root of 4, which is 2. And square root of 5 is still inside. So finally, what we have, 18 times 2, which gets me 36. 36 square root 5. That's my final answer. Alright, multiplying, dividing, simplifying. So last up is rationalizing the denominator. In math, we don't like having denominators, square roots in the denominators. For various reasons. One reason is when you compute things, it's easier to multiply by square roots than it is to divide by square roots when you're approximating things. So we don't like dividing by square roots. Also, when you get to upper level math, pre-calculus and above, you will start seeing expressions and equations that can get very long with a lot of square roots thrown in them. And one of the ways we simplify an expression or simplify an equation is by getting rid of square roots. More specifically, the method to get rid of those square roots is the same method we use to rationalize the denominator, to get rid of the square root at the bottom of the fraction. So the way you do that is you multiply the top and the bottom of that number fraction by the same number. Square root 3 is in the denominator, so we multiply the top and the bottom by square root 3. Here's the reason why. Off to the side, let's make a note. What's square root 3 divided by square root 3? I tell this to all my students and many of them were stumped. So I give them this example. Two divided by 2 is 1. 5 divided by 5. 2 divided by 2 is 1. 5 divided by 5 is 1. 92 divided by 92 is 1. When you divide the number by itself, that equals 1. So square root 3 divided by square root 3 equals 1. So really, what we're multiplying here, what we're doing is multiplying by a 1. And we know in math when we multiply by a 1, that doesn't change the number. 1 times 1 is 1. 3 times 1 is 3, 5 times 1 is 5, 10 times 1 is 10, 11 times 1 is 11, 58 times 1 is 58, and so on. Multiplying by 1 does not change the number. So when you multiply by 1, you are not changing this value. It still has the same value. But mathematically, we can work this out. When you multiply a fraction, as a reminder, the top gets multiplied with the top. So 1 times square root of 3 is square root of 3. The bottom gets multiplied with the bottom. Square root 3 times square root of 3. Because they are both inside a square root, you can multiply them. 3 times 3 is 9. So that's square root of 9. Which we can further take and simplify. We know square root of 9. We can take square root of 9. Square root of 9 is a perfect square. Square root of 9 is 3. And on top, we still have square root 3. And there's your answer. Square root of 3 over 3. So one last note to the side here, because this will be very helpful when rationalizing denominators. Square root 6 times square root 6 gets me square root of 6 times 6, 36, which we can take the square root of is 6. I'm picking random numbers here. Square root 9 times square root 9, which is square root of 81, which gives me 9. Notice the pattern. When you multiply a square root by itself, the square root just disappears. And this is a handy trick for rationalizing denominators. Alright, so there you have it, radicals.